Now with factoring, we're pretty much reversing this process. Instead of starting off with our factors and multiplying together, we start off with our trinomial sometimes it's binomial, and work backwards to try to find those individual factors. And to do that, we have a couple different strategies that we can use. Our first example, we're looking at a strategy of, do all the terms have something in common? So here's what my problem might look like. Let's factor 6n squared plus 9n. And right here, 6n squared plus 9n. Well, let's ask ourselves, do all the terms have something in common? Well, are all of these coefficients divisible by a certain number? 6 and 9 are both divisible by 3. That's my greatest common factor. And then n squared and n both have an n in common. So 3n times, now let's kind of reverse distribute here. 3n times what gives us 6n squared? 3 times 2 gives us 6. N times n gives us n squared. Plus here, 3 times what gives us 9? It's 3. N times just 1 is n. So 3n times 2n plus 3 is our answer. This is how we would factor our 6n squared plus 9n. And I'll just do a B example here too in the same video to go along with it. If you understood that 1A, you can stop this one and go on to the next one. But we'll factor another one here. Let's factor 27x to the third minus 9x squared plus 3x. And now I have a trinomial here, but that's okay. We can still factor this from here. 27x cubed minus 9x squared plus 3x. All of these coefficients are divisible by 3 and all have an x that we can factor out. 3x times 3 times 9 is 27. X times x squared gives us x cubed. Now we minus 3 times 3 gives us 9. X times x gives us x squared. And last, 3x times 1 gives us 3x. Okay. As of now, this is as far as I'm going to go with this. There is a chance that maybe we'd be able to factor this stuff inside a little bit more, but we'll save that for our next strategy for factoring.